Okay, so in this video we are going to look at resistors in series. So for us to look at resistors in series, let's do a sketch of an electric circuit with a few resistors. Alright, so I'll start with a source here. Alright, and then I'm going to have 3 resistors. That's my first resistor, second resistor, and then my third resistor. And then I simply complete my circuit. Alright, so this is my circuit here. Alright, and I can consider this to be V1. Let's call this V1, and let's say this has a voltage of 5 volts. Then we can let's say this is R1, this here is R2, and this here is R3. So that's my source right here, and my 3 resistors, R1, R2, and R3. Now this circuit here, the resistors are connected in a series configuration. And the reason why we say that they're in a series configuration is because we have the resistors connected in a chain-like manner. So we have R1 directly connected to R2, directly connected to R3 in a chain-like manner. Right, so it's that basically the resistors are holding hands, similar to like when you're playing ring games, or you're holding hands in a chain. This is basically how the resistors are depicted. So they're in a chain-like manner, so we say that they're in a series configuration. Now a couple of things that we need to understand about resistors in series. The first thing is that the current flowing through the circuit or through each resistors in that series circuit is the same. So whatever current is flowing through R1 will be the same current flowing to R2 and will be the same current flowing through R3. So the current within the circuit is the same. Right? Now also we need to know how to find the resistance of a series circuit. Right? So basically we want to find out the effective resistance of all the resistors, the individual resistors in that series circuit. So resistance of a series circuit. Right, so the resistance for a series circuit, right, let's call that REQ, which stands for the equivalent resistance of a series circuit, is simply equal to R1 plus R2 plus R3 plus R3 plus whatever number of resistance plus Rn. So basically what we're saying that to find the effective resistance or the equivalent resistance of a series circuit, we simply add all the individual values of resistance, or we simply add all the individual resistances. So for example in this circuit here, REQ would be equal to R1 plus R2 plus R3, because we have 3 resistors, so we have R1, R2 and R3, and we simply take the sum of all these resistors. So we write R1. First of all, let me give some values for R1. Let's say R1 was 8 ohm, R2 was 4 ohm, and R3 was 3 ohms. So we can simply find the sum of these resistors. We say 8 ohms plus 4 ohm plus 3 ohm and taking the sum of these, alright, so I'm going to finish right here. So let me just indicate via arrow. So we'll go here. Alright, so we say Req is equal to 8 ohms plus 4 ohms plus 3 ohm. Right, and that is equal to 8 plus 4 is 12 plus 3 is 15 ohms. So that's the resistance of this circuit here. So basically what we're saying is that this resistance right here is the combined resistance that these three resistors offer to the circuit here. So basically we could simply redraw this circuit here with just a single resistor like this. So we'll redraw the circuit. This is my source. That's my source, right? And then I have my single resistor. And again, this would still be 5 volts. And this here, this now would be 15 ohms. Because this is the effective resistance that these three resistors offer to the circuit. So this was Junior Roberts. If there's anything in this video that was not so clear to you, please send me an email or post in comments below, and I'll do my best to clarify any misconception for you. Share this if you found it helpful. Subscribe, hit the like button, and share this if it could help someone. Thank you for watching.